Welcome to the DIY Honda Garage channel. Welcome to this diagnostic presentation on the DTC P0192 for the Honda CRV models from 2017 to 2022. This particular error code refers to a low voltage condition in the fuel rail pressure sensor circuit. Understanding this code involves examining the role and location of the fuel rail pressure sensor, which is crucial for measuring the fuel pressure within the fuel rail to optimize engine performance. The sensor ensures that the engine receives the right amount of fuel at the correct pressure for efficient combustion. With a low voltage indication, this could lead to performance issues like stalling, decreased fuel efficiency, or difficulty starting the engine. Throughout this presentation, we will methodically approach troubleshooting steps to effectively pinpoint and resolve the root cause of this issue. DTC P0192 signifies a low voltage condition in the fuel rail pressure sensor, an essential component in fuel delivery systems. This sensor measures the fuel pressure in the rail and communicates this information to the Powertrain Control Module, PCM, to ensure the engine runs optimally. The fuel rail pressure sensor is typically located on the fuel rail assembly, making it easily accessible for diagnostics. Its primary role is to help the PCM adjust the fuel injector timing and duration based on the real-time fuel pressure measurements. If the signal from the sensor falls below the expected threshold, as indicated by a reading of less than 0.31 volts, it flags an error, prompting a need for further investigation. Addressing this diagnostic code is vital to maintaining engine performance and efficiency. Several possible causes can lead to DTC P0192. First, a faulty fuel rail pressure sensor may fail to deliver appropriate readings to the PCM. This could be due to internal sensor failure or degradation over time. Second, a short in the PF wire, which connects the sensor to the PCM, can create a scenario where the signal voltage is compromised. Third, an open circuit in the VCC1 wire could prevent proper voltage supply to the sensor, leading to the low voltage condition. Lastly, issues with connectors, such as corrosion or loose connections, can lead to poor communication between the sensor and the PCM. Each of these causes necessitates thorough examination during the troubleshooting process to confirm or rule them out. The manifestation of DTC P0192 can reveal multiple symptoms, suggesting underlying issues within the fuel delivery system. One common symptom is engine stalling, which occurs when the engine does not receive the correct fuel pressure required for combustion. Difficulty starting the engine may also arise, as the low voltage signal could inhibit the PCM from effectively regulating fuel delivery during startup. Additionally, decreased fuel efficiency is often an indicator, resulting from the improper fuel-air mixture caused by erroneous pressure readings. These symptoms point towards the need for immediate diagnostic action to identify the cause of the low voltage and rectify the issue to ensure safe vehicle operation. Troubleshooting for DTC P0192 begins with verification of the problem. Start by turning the vehicle's ignition to the on mode and allow it to stabilize for about 2 seconds. The next step involves using the Honda Diagnostics System, HDS, to check specific parameters related to fuel pressure. Focus on the value for the fuel pressure converted from the fuel pressure sensor. The threshold for this reading should be over 0.31 volts. If it reads lower than this, you proceed to confirm that the failure is indeed duplicated. If the system appears operational at this time, intermittent issues may be present, prompting checks for poor connections or loose terminals at the fuel rail pressure sensor and the PCM. Understanding this initial step is critical, as it sets the foundation for further diagnostics or repairs. The second troubleshooting step involves determining the possible failure area. Begin by turning the vehicle off and disconnecting the fuel rail pressure sensor by removing the 3P connector. Once disconnected, start the vehicle again by turning the ignition to the on mode. Utilize the HDS to check the fuel pressure signal again. It should consistently read below the threshold you've noted, which is less than 0.31 volts. If it does, proceed to the next steps in your diagnostic flow. If the voltage is above this threshold, it suggests that the issue might be isolated to the fuel rail pressure sensor itself or potential defects in associated wiring. In this step, we will confirm if a short exists in the PF wire. First, switch the vehicle to the off mode. Jump the SCS service check switch line with the HDS and wait for at least 1 minute to ensure correct readings. After the wait period, disconnect the PCM connector C, which consists of 51 pins. Now, check the continuity between test points 1 and 2 under specified conditions. Test point 1 corresponds to the fuel rail pressure sensor connector's female terminal number 1, while test point 2 refers to the body ground. If continuity exists, it indicates a short in the PF wire between the PCM and the sensor. If not, the PF wire is functioning correctly, thus prompting further investigation into other possible failures. This troubleshooting step focuses on determining possible failure areas, particularly involving the fuel rail pressure sensor. Begin by measuring the voltage between specific test points while in the on mode, but with the fuel rail pressure sensor disconnected. Test point 1 is at the female terminal number 2 of the sensor connector, and test point 2 is at the female terminal number 3. A voltage reading around 5.0 volts indicates that the circuit is providing the necessary voltage to the sensor. If this reading is verified, it confirms that the fuel rail pressure sensor is faulty and is due for replacement. Conversely, if the voltage differs significantly from 5.0 volts, further investigation is required into the VCC1 line. In the final troubleshooting step, we will check for an open wire condition in the VCC1 line. After turning the vehicle off, repeat the SCS line jump procedure utilizing the HDS. Following that action, disconnect the PCM connector C again. With both the fuel rail pressure sensor and the PCM connectors unplugged, you'll check the continuity between 2 designated test points. Test point 1 corresponds to the fuel rail pressure sensor connector's female terminal number 3, while test point 2 is at PCM connector C, pin 41. If continuity is present, it confirms that the VCC1 wire is functional, leading you to check for other potential issues. If continuity is absent, it signifies a break in the wire, requiring repairs to restore proper connections between the sensor and the PCM. After conducting all necessary repairs, it's crucial to perform a final verification to ensure the issue associated with DTC P0192 has been resolved. First, confirm that the fuel rail pressure sensor has been properly replaced, if required. Next, utilize the HDS to recheck the voltage signals coming from the fuel rail pressure sensor. Ensure that they now fall within the appropriate thresholds. Additionally, inspect all relevant connectors for any looseness, corrosion, or poor connections to guarantee optimal communication with the PCM. Completing these checks will help ascertain that the vehicle is functioning correctly, thereby confirming that the repairs were successful and that the initial DTC P0192 has been resolved. To avoid recurring issues associated with DTC P0192, implementing preventive maintenance is essential. Regularly inspect the wiring harness connected to the fuel rail pressure sensor and PCM for any signs of wear, fraying, or damage. Ensure that all connections are clean, secure, and free from corrosion, which can impede electrical signals and lead to sensor errors. Additionally, it's beneficial to perform routine diagnostics on the engine, which can catch problems early before they develop into more significant issues. Engaging in these practices will not only enhance vehicle performance, but also prolong the lifespan of the fuel delivery system. In conclusion, the diagnostic code DTC P0192 indicates a low voltage condition in the fuel rail pressure sensor circuit, necessitating careful investigation. Identifying the root cause can stem from various factors, including a faulty sensor, wiring issues, or connectivity problems. Following a structured troubleshooting approach allows technicians to systematically rule out possibilities and arrive at an accurate diagnosis. Additionally, ensuring proper sensor functionality post-repair is crucial in restoring normal operation. By implementing preventive maintenance practices, the frequency of such issues may be significantly reduced. Effectively addressing DTC P0192 ultimately leads to improved vehicle performance and reliability. Please like and subscribe to the channel. See you next time!